the PowerPoint, correct?
Yes.
All right, so my
Yes, we
project,
can see it.
awesome. So my project was on the called the Course and Faculty Management System. Purpose of the paper and project were to expand the low-code framework provided to show how it can be used to develop various web applications that fit a broad variety of needs. The goal of this project was to complete my computer science senior capstone project. It was mainly programmed in PHP, JavaScript, MySQL. That's structured in HTML, styled in CSS, running on Apache web server. So the Course and Faculty Management System is a data management system designed for educational organizations like universities, so they can effectively organize and organize their courses and faculty. It's a web application. It's responsive, interactive, dynamic, database driven, and it is has user authentication built into it. Users that are logged in have proper permissions assigned, can edit, add, delete courses, departments, instructors. Admins are going to be able to mass import, mass export lists of courses from a CSV file, as well as edit user permissions. For universities, course management systems are very important because they are a way to help organize the scheduling of courses and manage instructors' times. A lot of smaller universities don't, without like access to these larger course management systems, end up using smaller spreadsheets, which end up taking a lot of manual entry. Spreadsheets get passed around person to person, data gets misentered, lost. So course management systems do a lot of automation to make sure the time constraints are validated, that the data is correct going into the system. The purpose of the paper is to show how the low-code framework by Yank and Butler is able to be expanded to fit a broad need of different applications. The framework is based on a PHP MySQL. So the University of Verne has multiple systems to manage their course offerings. They don't really communicate well with each other. So to bridge the gap, the office administration often uses spreadsheets. They copy data out of one, paste it into the other. So the overall future goal of the course and faculty management system would be to automate those changes. So system design is designed in layers. We have the UI layer, we have the two server-side layers, business logical data access layer, and we have the MySQL database layer. The UI, where the users can view, add, update, delete any information related to courses and instructors. Backend will take anything entered into the UI layer, perform calculations, validate, clean the data, insert it into our database by running queries on that MySQL database. The website conforms to best design practices. This is the public view. We also kind of have two main views for the course management system. We have the public and we have the admin view. So this is designed to be the homepage, kind of a dashboard layout for easy navigation. We have one of those, say, courses. We would end up at the public view of the courses page. If you're not logged in or don't have editing credentials, we'd be able to filter by term, attribute, subject. Below that, we have a very nice, clean, concise, easy to read table listing those courses in the system. Going forward, if you have the permissions assigned to you to edit or delete, you would see the edit, delete buttons on the courses page. Below also, if you have these permissions, you would see that Professor Goetz has two courses with a conflicting time down below. So that would give whoever's preparing the schedules a little alert notification to go and change that, because can't have Professor Goetz in two spaces at one time. This is an example. If you click the edit courses page, notice we have some drop downs there. Those are all foreign key primary key relationships to data stored in other tables. So we can grab anything from our list of courses, terms, subjects, etc., stored in our database and apply that. Instructors are done this way as well. Similar to the courses page, we can see that the public and admin pages are very similar. We've got the table format listed. If you click the name of the instructor, it'll take us to the instructor details page, where if you have permissions, you can see pay info, you can add, edit, delete courses. We can see the courses the instructor is an instructor of, as well as some more about that instructor here on the instructor details page. The edit instructors page is where we can edit anything related to our instructors. We can also add and edit permissions for the instructors if they're a user of the application. So we've got permissions for courses, departments, pay info, importing and exporting here. Public and admin department pages look very similar to the others. It's to keep that UI nice, clean, and concise. Here we have our upload courses page and export courses pages. So it gives you the formatting of the CSV you need to upload courses into it. And it also does validate the information you're adding. So if you have, say, a campus that doesn't exist in the database, it will give you a little notification saying, hey, you don't have this campus, you're going to have to enter that campus and resubmit the course data. This is our database relationship table. We've got our two main tables. We've got courses and instructors, as well as the supporting tables, just time slot, campus terms, all connected by foreign key, primary key relationships. This is our verification matrix. Every single page in the application is manually tested. Every single button on that page, every single input on those pages are also tested. So if a field is required, we test that it can't be sent to the database blank. We test that number fields can only get numbers. In column 3, you'll see that we use a validator to make sure the HTML structure is correct. We also test to make sure the application looks good on mobile, medium-sized screens, and large desktop screens. So I can take you through, just click around the website real fast, couple minutes here. We can go to the homepage here, and this is not logged in, it's public view. So we can click courses, and we'll see our list of courses in this format. If we go ahead and log in and register, apologize about that, and log in with KeyPass here. We'll see that the permissions give us many more fields so we can edit and view. So we've got time slots, say campuses. We have our upload courses, instructors. We can click an instructor here. You can see the information, the courses that instructor is an instructor of. Be able to edit those courses here, all this information. Go back to instructors. We can also say edit any permissions this instructor has to give them some admin privileges here. We can move forward here. Professor Goetz, do you want to take over on this part?
Yes. Okay, you have finished your demo, right? Okay.
Correct.
Oh, you have, okay, great. The course and faculty management system, this is our application, is an emerging application. Therefore, it is limited in features. The current version allows privileged user to perform, create, read, write, and delete operations. Our limitations are related to the permissions that are not notified to user whose permission have been changed. The user can only filter courses, but in our expansions, we are thinking to add ascending and descending order feature for each column, and introduce a two-factor authentication security subsystem, and add additional filters and search functionality for the courses and instructors to implement for any attributes. Moreover, to build a notifying system around the managers. And in addition to have upload and retrieve binary files in order to display photos for instructors. And we think about adding data analytics, for example, Google Analytics, and to create report generations, contracts, reports for to have contracts for the instructors. Next, please. Before the goal of this work is achieved within the computer science senior project by studying, learning, expansive, secure framework for the purpose of designing, implementing, and testing course and faculty management system. And the main goal of the senior project is to provide a capstone experience in which students combines knowledge, skills, and topics with already new topics already learned by the students. All computer science undergraduates are required to take a capstone course senior project at the University of Verne, but also in other universities according to computer science curricula. Moreover, the student, as a senior project, satisfied the following program criteria according to Accreditation Board for Engineering and Technology, ABET. One of the criteria is ability to design, implement, and evaluate a computing-based solution to meet a given set of computing requirements in the context of the program and discipline, program's discipline. Before starting work on a senior project in another class, class is prerequisites, that 320 Internet Application Development students learn how to construct dynamic data-driven web application and secure customized management system using PHP and MySQL. Therefore, many new additions to the various PHP HTML framework files were successfully added or modified to achieve the well-structured full functionality of this application. And the design, implementation, and testing of this application with a wide spectrum of functionality is an excellent proof of the senior project achievement beyond regular computer science 499 requirements. The content database itself and the admin component of the course of this application provides a strong foundation for expanding the functions of the website. We have a lot of references, and one of the references is that you could find the code on the course and faculty management, which is here. And you can go to GitHub and find a full working code. And moreover, you see here references of the first one, second one, and the fourth one, which use low-level code by extending to other applications. And one is certificate management applications, Another is patient care reporting application, and another one is mapping temperature and pressure into the map and show on the internet. And I think this concludes our presentation. If you have any questions, let us know, please.